Hi everyone, this is Dr. Gopal Sivakumar. Welcome to the part 2 of my video on understanding p-value. So let me share my screen with you. Yeah. So in this particular module, part 2, we will be discussing calculation of p-value for discrete data. And already in the part 1 video, I spoke about the meaning of p-value. The link of my part 1 is given in this description. And in the next video, I will be discussing on calculating p-value for continuous data. Now let us proceed with this part 2, which is calculation of p-value for discrete data. Now first let us understand what is discrete data. So discrete data are quantitative data. Discrete data or quantitative data, they are generally countable data. It is always a whole number. And between any two values, only discrete number of values are possible. If you observe all these statements to be true with respect to your data, then definitely your data is a discrete data. Say, for example, the number of defects you observe in your product, and generally there could be 10 different types of defects. So what will be the number of defects? It will be a number between 0 and 10, and then it is always a whole number. You cannot get 1.5 defects or something, right? Number of rejections, the score in a beauty contest, between 0 to 10 some score will be given. Customer satisfaction score, number of customer complaints, and these are all discrete data, right? And now p-value for discrete data. What is this p-value? P-value is probability of significance that determines the appropriateness of rejecting the null hypothesis in a hypothesis testing, right? And when to reject the null and when not to reject the null, and we take this important decision based on the value p-value. And p-value generally range from 0 to 1. And right now we are going to learn how to calculate this p-value manually, and then that too for discrete data. And let us consider an event, right, to better understand. Let us consider tossing a coin. And now, what is the sample space while tossing a coin? Sample space is nothing but a set containing all possible events. When I toss a coin, I could get only either a head or a tail. So I include both in a set, and that becomes my sample space. Now let us consider the event of interest to be getting a head. So the favorable event is getting a head. And what is the probability of getting a head? 0.5. And now what is the probability of significance? It is 1. And so probability of significance is different from the probability, and the probability of significance is always more than the probability of the event observed, right? And so let us see the calculation behind. So what is the probability of the event observed? 0.5 as it is. And what is there a event, an equal event in this case? Yes, look at the sample space. Just like head, you also have another event, tail. That also has got equal probability. So there is an equal event, and for which the probability is zero point 0.5. And then probability of the rarer event. What is the rarer event? Is there anything beyond head and tail can happen while tossing a coin? No, nothing can happen. So the rarer event is absolutely 0 here. If you add all the three probabilities, the resulting probability is called p-value. Now add the 3.5 plus 0.5 plus 0, and how much it comes to? 1. So this is the calculation behind p-value. For any event that you are observing in your study, always there is an associated p-value, and that p-value can be calculated in this manner provided your data is discrete. And now let us consider another event. Now I am going to toss two coins. Now the sample space will have four possible outcomes. both heads, both tail, or head in the first coin or head in the second coin. So these are the four possible outcomes that constitutes your sample space. Now once again, let the favorable event be one head. When the favorable event is one head, what is the probability of getting one head? And there are two events that contains one head, right? And so out of the four, two or favorable. So 2 by 4 is once again 0.5. And once again, the probability of significance is 1. How it is? Let's use the same logic. Probability of the event is zero point 0.5. Is there an equal event like getting one head? No, there are two events. Both we have already accounted. And so there are no other event, right? Like getting one head, getting one tile is a parallel event, is is the say almost the same event. And so probability of equal event no need to be included here, because that was already included here. When the head happened, the same time the tail happened. And probability of rarer event, when what is the rarer event? More than one head, yes, there is a rarer event. Getting two heads, when you get getting two heads is a rarer event. And similarly, getting two tails is also a rarer event. So I can calculate the probability of the rarer event, that is also zero point 0.5, because 2 by 4 is zero point 0.5. And so the sum is zero point 0.5 plus zero point 0.5. Once again, the p value is 1, right? Now let us consider another event. Now we are tossing three coins, and let us consider getting two heads as our favorable event. And so two heads occur no twice. The sample space contains 8 outcomes. So there are one, two heads, and one more here. See here, one more two heads. So let me change the color of that also, so that you will be able to better appreciate. Yeah. So the three events contained two heads, so 3 by 8. And probability of significance is again 1, is almost 1. So what is the probability of the event? 3 by 8. Probability of the equal event, when you have two heads, same way, do you have an equal event? Two tails? Yes, there is an equal event. Two tails, 1, 2, 3, again three events, so 3 by 8. And rarer event, getting three heads or getting three tails. These are definitely a rarer event. So this rarer event is 2 by 8. And so when I sum up all the three, again it becomes 1. So my p value is actually 1. Now let us consider one more event. Tossing three coins and getting three heads. Tossing three coins, you all know the sample space will be 8 outcomes, 8 possible outcomes. Three heads, it occurs only once, 1 by 8.125. Now, probability of significance. Is there any equal event? Do you have any three tails? Yes, there is one equal event, 0.125. When I toss three coins, I can get only maximum three heads. There is no rarer event. So 0.125 added with 0.125 will give me 0.25. That 0.25 is the probability of significance. Now, another event, tossing four coins. When I toss four coins, there are about 16 outcomes possible. All the 16 outcomes I have listed here. And now let us calculate the p-value for getting three heads. And how many times I could get the three heads? See here, the third line, three heads, three heads, three heads, three heads, and 4 out of 16, right? And the p-value for this particular event is 0.625, because the probability of the getting three heads is 4 by 16. Is there an equal event? Yes, probability of getting three tails, that is an equal event. And probability of rarer event, what is rarer event? More than 3. 4 heads is one possibility, and 4 tails is another possibility. So that is 2 by 16. And so total is 10 by 16. The p-value is 0.625. And one last example, even number 6, tossing 4 coins. There are 16 outcomes. Getting 4 heads. Getting 4 heads is only one event out of the 16. So 1 out of 16. And now probability of significance is 0.125. Probability of significance is 0.125. And how it is arrived? Probability of the event is 1 by 16. And probability of equal event, is there an equal event? Yes, like how you get 4 heads, 4 tail is also no, possible equal event. So that is 1 by 16. and rarer event you cannot get 5 or 6 hits here. So there is no rarer event, and so the sum is 2 by 16. So it is 0.125 is the p value. Now looking at the p value, now it has become very very low compared to all the other cases we have seen, indicating that indicating that getting 4 heads while tossing 4 coins is really really a significant event, and that the probability of that event becoming significance is 0.125. That means there is 12.5% chance is there you could get 4 heads. You could get 4 heads, in a random by a random chance. Right? That's the meaning. Okay. So this is the summary of all the events we discussed: tossing a coin, tossing 2 coins, tossing 3 coins, and tossing 4 coins, and 1 heads, 2 heads, 3 heads, and then 4 heads. And slowly the probability of significance is going down and down. And in the last case, it has become 0.125. And here, none of the event is actually considered significant, and because everywhere the p-value is more than 10%. So even at a 10% level of significance, I cannot consider any of these event as significant, for the simple reason that p-value is more than the 10%. So always, p-value must be compared with the level of significance in your study, and if the calculated p-value is more than the level of significance, you must conclude the event as insignificant, right? And this is what. So stay tuned for my next video, where I will be explaining to you about p-value for continuous data, right? If you like my videos, please do share, comment, and subscribe. Thank you. It's Dr. Gopal Sivakumar signing off from you.